Okay, so this is the first, well, the second PowerPoint lecture for Chem 111, and there's two more, and these are really going to be the basics, what you're going to have to know for the first test. This one covers parts A, organic chemistry. Real small introduction to organic chemistry. Organic chemistry is the study of carbon hydrogen compounds, covalent compounds. It was first developed in the mid 1800s when it was discovered that we could make molecules of life in the laboratory, and they were called organic because they from living organisms. And so one of the things they found out about all living organisms is that they were mostly made out of hydrogens and carbons. So they called it this science of study of compounds that are mostly hydrogen and carbons, organic chemistry. Now there are different types of organic chemistry. One of the types of organic chemistry is to study things like petroleum, which is oil, gasoline, plastics, and all that good stuff. Okay, and that comes from the ground. And why is that? How's that related to living things? Well, all that stuff, all oil and petroleum and gas and all that, it comes from things that were alive long ago and decomposed. So when you fill in your car up with gasoline, what you're doing is you're filling it up with old dead things. Now, what has happened is those old dead things have lost some of the elements from their compounds, and they're just mostly now hydrogens and carbons. So another study, subset of organic chemistry, is the study of living things, and we could call that biological chemistry or biochemistry, and that's what we're going to eventually study here. But all living things and dead things have something in common. Well, at one time they're all live, and they're made out of mostly hydrogens and carbons. So what we're going to do is we're going to start this out with a basic overview of the study of hydrocarbons, which is sort of the big world of organic chemistry. And then we're going to go into biochemistry, which will start to include oxygens and nitrogens to our molecules, our hydrocarbons, and these will produce the molecules of life. Okay, the first type of organic compound we're going to cover is the most basic organic compound, and if you ever plan on going any further into chemistry, especially organic chemistry, there is a discipline of organic chemistry. You will start off with what we're learning today here in this PowerPoint. So we're going to start out with things called saturated hydrocarbons. So let's just take a look at the word here, saturated hydrocarbon, and sort of give you a heads up where you're headed. So saturated. So saturated doesn't mean like filled with fat or filled with whatever. Okay, it definitely means filled. Okay, and we'll talk about that in a minute. So hydrocarbons are filled. What are they filled with? And we'll get to that in a minute. Hydrocarbons, hydro means hydrogen and carbon means carbon. So what we're looking at is saturated. We're looking at molecules that have hydrogens and carbons and that are filled with something. Okay, and we'll get that in a minute. These particular molecules are called alkanes. Now, if you had me for Chem 110, you probably, hopefully, these look very familiar to you because there will be 10 of them, and you'll have. Okay, molecular formulas, structural formulas, and isomers. Okay, so if you had chemistry before, we talked about molecular formulas and structural formulas, and so let's just move on to this. Is that, like it says, we're going to be dealing with we're not going to deal with the dot structures. The dot structures will lead to what we call the structural formulas, but we won't be building molecules using Lewis dot structures. We'll be using the information that we went over in the last PowerPoint, that carbon has 4 bonds, nitrogen 3, oxygen 2, with their associated lone pairs, instead of try to generate molecules based on matching dots. So just to review, a molecular formula is tells you exactly how many atoms and a type of atom and the number of those molecules. All right, so this molecule here, there's some molecule with the formula C2H6O. All right, and then you got something called a structural formula, which will show you the actual, shows you a two-dimensional version of that structural. It sort of gives you what it looks like as if it was in 2 dimensions. So we have two structural formulas here, and the curious thing about them, they both had the same chemical formula, C2H6O. But when you draw them out, you can see that they have different structural formulas, or structures, bonding structures, and you can see that everything works here. Each carbon has 4 bonds. Each oxygen has 2 bonds and 2 lone pairs, and each hydrogen has 1. And that's for both structures here. So you may go, it's kind of odd that one chemical formula can give 2 structures. Well, it just so happens you can do that because this just gives you a relationship. It doesn't give you the actual connectivity. Okay, so since these guys are the same formula, different structures, we call these structural isomers. And we'll be talking about both of these structures in this the next material when we get into test 2 material. So you have structural isomers, which means that they have the same formula but different structural formulas. And we'll see and they're called isomers, and we'll see this really will play in the next few slides. Okay, so you have molecular formula, which gives you the relationship of atoms and number of that type of atoms in a structure. And then you have the structure, which shows you the connectivity of the atoms in the molecule. All right, so what we're going to do is we're going to focus on the most basic organic molecule called alkane. Again, alkane is a hydrocarbon and it's saturated. Okay, and why is it called saturated? Because there's nothing but single bonds between the carbon atoms, and what that means is that this structure will have the maximum number of hydrogens attached to it. Okay, so it's filled with hydrogens, and you'll see that in a minute. Again, hydrocarbon here. All right, so let's get started. Again, you have alkanes are described as being saturated. So here you go. This definitions, and you'll see it more. So we'll also see is that alkanes there'll be different alkanes. We'll see that in a minute. But a lot of the alkanes will have isomers. Okay, you're going to be responsible to know the first 10. And let's just get to that. Okay. All right. So the first alkane is called methane. All right. Methane has a chemical form, molecular form of CH4, and its structural formula is simply this here: 1 carbon and 4 hydrogens. And we'll talk about condensed structure formula in a minute. Okay. Which looks like the molecular formula, but it's slightly different. You'll see that in a minute. So one thing to notice here is carbon has 4 bonds. All right, so the shape around this this molecule is tetrahedral, and that's going to be important because all alkanes have the shape of all the atoms of the center atoms of alkanes are tetrahedral. All right, let's go to 2-carbon. So a 2-carbon alkane. Okay, looks like 2 carbons bonded together. Remember, hydrogen can't bond; it can only bond to one thing, so it's always to be on the outside. And so it's C2H6. The structural formula is this, or structural bonding structure. And the condensed formula, here's what you can see, is that what we do is that we kind of condense the hydrogens into one piece here, instead of drawing them all out. And this is kind of just easier to write out. This takes up quite a lot of space. This doesn't. And we're going to even have simpler ways of describing these in a little bit. And then you have 3 carbons called propane, and each carbon has 3. The way this bond should be connected here, and the condensed formula is CH3, CH2, CH3. Okay. One thing to notice about the condensed is always the end guys will be CH3s, and the middle guys will be CH2s, or sometimes CH. Right? You'll see, or just C, and you'll see how that ends in a minute. Okay, here's your 4-carbon. This guy's called butane. And there's condensed form. And then there's 5. Okay. Pentane. Alright, so, and then you have the other guys. So you have hexane, and what you would have is 6 carbons all connected with each other with the associated hydrogens coming off. Alright. And you should be able to draw all of these. Okay, and here's a picture of all the ones you need to know. Okay, so you have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. And if you notice formulas, CH4, then when you add 1 carbon, you add 2 hydrogens. And you can see that plays all the way down. So if you know methane's formula, you can figure the rest out, because every time you add 1 carbon, you add 2 hydrogens. Okay, and you're going to have to memorize these. The way I kind of remember them is they start out with number 5, pentane. I know, and I don't know if you guys know, but it's good to know this. But pent means 5, like pentagon. So if it tells you that's 5. Hex means 6. Hep is 7, 8, like octopus. Non, and dec, like decade. Okay. Now the first 4 don't look like that. This is not monane, diane, triane, and quadrane. Okay. These guys were named before they knew the structures. So one way it helps me remember these first 4, because I know the prefixes, and so to help me remember the first 4, I sort of have a mnemonic, and that's MEPB. Meat eaters prefer beef. MEPB, or bacon, or beer. So methane says meat eaters prefer beef. Okay, and then the others use typical prefixes. And you got C, 1C, 2C, and so forth. Now, if you look over here, here's the condensed formula for each one of them, each long chain. And they're easy to remember. Okay, notice you just add 1 more carbon all the way through. Okay. All right, so let's take a look at this guy. This is butane. It has 4 carbons. So meat eaters prefer beef. Butane. Okay. So methane, ethane, propane, butane. So you could draw it like this, but I like to just draw it as long as I know that it's an alkane. I'm going to leave the hydrogens off because I know carbon has 4 bonds, and any bond I don't show is a carbon-hydrogen bond. So I'm going to just make this a shorthand for drawing this structure here. Okay, and that'll be convenient. Okay, so All right, so let's take a look at this molecule here. All right, is it the same as this molecule? Or is it different? Okay, so the one thing about alkanes and saturated hydrocarbons is single bonds can twist and turn and be in different orientations. So this guy is the same molecule as this. So these are both butanes. So you can draw this structure as straight across, so you could have a bend like this. You could even have it another version where you have carbon here, carbon here, carbon here, carbon here. Or you could flip it upside down and have them point that direction. So it really doesn't matter how you draw this as long as you have the connectivity right. Okay, so now let's look at this one right here. Okay, is it the same or different than butane? So this is butane. Well, look at this guy. It has 4 carbons, and if you count up the number of hydrogens, this has each carbon has 4, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would have C4H10. So it'd be 3 here, 2 here, 2 here, and 3 here. That's the number of hydrogen. Well, how about this guy? This guy here has 4 carbons. This one would have 3. 1, 3, so that's 7. And then 3 more is 10. So this guy here is also C4H10. So this has the same chemical formula as butane, but it's not the same structural formula. You can't twist this carbon to put it here. You'd have to break this bond to put it here. Okay, so this is a different structure. So this is an isomer of butane. Okay, so it's a butane-like molecule in terms of its formula, but it's not butane. And so what we have to do is we have to come up with its name, because it is not butane, because butane is this. So here's the 3-dimensional structures of what you kind of look like. So remember, so each carbon has 4 bonds, okay, and 4 things attached to it. So each one of these carbons would be tetrahedral. And if the way that we draw them out that they're just straight chains. But this is what they sort of look like in reality. Okay, so we drew this so that you could sort of get a view of this as 3 dimensions. Okay, so this is butane. Okay, and what you could do is you could twist this guy up here, just or down, like we had in the previous one. Now this one is that isomer. So here's the 3 carbons, then you have this carbon come off of it. Now notice each carbon has 4 attachments, so that each one of these is a tetrahedral as well. So all the carbons in alkanes have tetrahedral shapes. So we're in this kind of a dilemma. We have this guy here, and what we want to do is name it, because it's not the same as this one here. Right, and that's what we're going to go through. So this guy's going to have name. It's going to be the name will relate to we're going to look at the longest chain. In this case, it's going to be a propane. It has 3. Okay, so it's 1, 2, 3. So that's kind of, we call it its parent name. So it's propane. And then it has got 1 carbon. So we knew that 1 carbon alkane was called methane. What we're going to do is call this group out here a methyl. So this would be, so that's kind of like its first name. Its last name is propane and its first name is methyl. Another thing is, well, we like a little bit more, so we can tell where it comes off here. But you could just call this methyl propane. And we're going to go through the technique of naming isomers of alkanes. Okay. So we're going to look at the branch parts, and the branch parts are going to be called alkyl groups. Okay, and they're going to stick out of the chains, and we'll see that. All right, so these groups that stick out, like in the methylpropyl, I will have the methyl group sticking out. What you do is you replace the ane with the YL, and sometimes they're called radical or side group. All right. Okay, so for instance, methyl, that side group or alkyl group is called methyl. So this is a methyl, and it's attached to some straight chain. And we'll designate it as CH3 for its condensed form. If it has two carbons coming off the parent chain, it's called ethyl. And you could either draw it like this, or just two C's. And then if you have three, that would be called propyl. Okay, and you keep on adding, but we're just going to deal with these three alkyl groups: a methyl, ethyl, and a propyl. You get butyl, pentyl, and so forth. But if once you know these basic ones, hopefully you'll get the rest of the terms down. Okay, so let's go about naming different isomers. This this structure has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is alkane with 11 carbons. So its chemical formula would be C11. The number of hydrogens would be twice that. 22 plus 2 is be 24. So this would be C11 20 H24. And I don't know what the name would that be, the long chain. It doesn't matter here. So what we want to do is find out what it's named, because it isn't a straight chain. It has branches coming off, so it's an isomer of the C11 version, a straight chain. So let's come up with the name of this. So the first thing you're going to do is you're going to name the longest chain. Okay, and so what you have to do is actually work it out. So 1, 2, 3, 4, 5, 6, 7, 8. Now I know I haven't read here, but what you need to do is actually check to see if there's other ways to get long chains. So maybe if I go like this, maybe this will give me a longer chain. So 1, 2, 3, 4, 5, 6, 7. Nope, it doesn't. And so what you got to do is kind of just, usually it'll be a straight one across, but we're going to see in the future that sometimes it's not. And like these two guys could be bent off down in this direction. So it would be 1, 2, 3, 4, 5, 6, 7, 8. And so you'd have, so this would be the longest chain. So longest chain doesn't always have to be straight across. And it doesn't always have to go left to right. It can go right to left, or up to down, or down up. And we're going to see all those cases as we go along here. So the first thing to do is find the longest continuous chain. And that's 8. And so what we do is we name this kind of like its parent name or long. So here you go. So octane. And if you notice, each carbon has the right number of bonds. This carbon has 3 hydrogens and also bonds to this carbon. This carbon has 2 hydrogens, and it's not bonded to these H's. It's bonded to this carbon. So all the carbons are bonded to each other, and the H's are the ones sticking on the outside. All right. Okay, next thing you do is you label your alkyl groups. Okay, so this is a methyl, has 1 carbon, and this is a 2 carbon ethyl. So far we have this guy, sort of like his first name, it's methyl ethyl octane. So, but the issue here is that this methyl could be coming off of any of the carbons in the middle here, and same with the ethyl. So what we're going to have to do is be very specific on which carbon these guys come off with. So what we do now is we number each of the carbons in the octane. So we can go left to right, or right to left. So the green is left to right, 1, 2, 3, 4, 5, 6, 7, 8. So this carbon 1, carbon 2, and the purple one, it goes the other way. So this is carbon 1, and like I said, you can have it go either way. And if you want, what you can do is you can just flip this guy the top one and you would get the bottom one. So that's sort of why you can do that. So what we want to do, which direction is the best? Well, what you do is you're going to look at each of the side groups and see which carbon they come off. So for the first version, the methyl comes off at 3 and the ethyl comes off at 5. So I put that over here, 3, 5. And the bottom one, going right to left, the ethyl comes off at number 4 and number 6. Okay, so you have going right to left, it's 4, 6, and going from left to right is 3, 5. What you do is you pick the smallest numbers. So 3, 5 is smaller than 4, 6. So I'm going to go left to right in my numbering. So now what we do is we put the numbers associated with our side groups. So now what we have is you have put the 3 with the methyl, it comes off in number 3, and put the 5 with the ethyl because it comes off in 5. So far we have 3 methyl, 5 ethyl. And right, okay. So now the next thing you do is you have all the parts. You have 3 methyl, 5 ethyl, and you have octane. So how are you going to put that all together? Okay. So you got to put all these, you got to put the 3 names together. And who do you put first in terms of the either 3 methyl or 5 ethyl? It's always alphabetical. So ethyl will be going before methyl. So the answer is 5 ethyl, 3 methyl, octane. Okay, so the procedure will be find the longest chain, number it, okay? Number it according to give you the smallest numbers, and then label each alkyl and put the names together. All right, so let's do this guy here. Okay, so this guy here, you find the longest chain. Well, what we're going to do is I'm going to redraw it like this here. I'm going to get off the H's because I know each carbon has 4 bonds. So the only bonds I'm going to be interested in is the carbon-carbon bonds. Any bond that any carbon is missing, it's a hydrogen. So this is sort of a skeletal picture of this structure here. So you find the longest chain. So 1, 2, 3, 4, 5, 6, 7, 8, just like the one before. Then you can try different versions. Okay. Go up, down, and so forth. You find that this is the longest chain. So this again is an octane. Right, next thing you want to do is you want to number it. So you can number it left to right or right to left. Well, actually, we're going to do what you do is you label the side groups methyl, ethyl, and methyl. And then what we do is we number them 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, what you do is you pick, so if you go right to left, the methyl, you have methyl come off at 3, ethyl 5, and methyl come off at 7. So you have a 3, 5, 7. And, or you would have, if going from right to left, you would have methyl coming off 2, 4, and 6. And you can see that this numbering order is less than this numbering order here. So we're going to use this ordering here. So now what we have to do is we have to put all these guys together. So what you do is you put methyl first, so 4 methyl, 2 methyl, 6 methyl octane. All right, now there's a little problem with this. Well, that's not really a problem, but it's just a method. Is that if you have 2 of the same alkyl or side groups, what we do is we don't write it as 2 methyl, 6 methyl. What we do is we put those 2 methyls together and call it dimethyl. So the official name is 4 ethyl 2 6 dimethyl. All right. Octane. All right, so let's do another example. So we have this guy here, and what I'm going to do is I'm going to write the skeletal structure of it like this here. Okay, so first thing you do is you find the longest chain. So the longest chain is All right, that right there. So there's 1, 2, 3, 4, 5, 6, 7. So the longest chain is heptane. Okay, so this is the parent chain. All right. Now what you do is you circle the alkyl groups and you name them. Okay, so you have 2 methyls here. All right. So what we have so far is we have 1, 2, 3, 4, 5, 6 heptane and 2 methyls. Again, if you have 2 methyls, this will end up being a dimethyl. All right. So what we want to do now is find the direction that's best. If we start from this carbon here, it would be 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. It'd be 3, 6 going. So it'd be going this way. It'd be 3, 6. And going this way, it'd be 2, 5. All right, so we're going to go this direction here for the numbering. So this is 2 methyl, 5 methyl. All right, so then you put it together. So you have 2 methyls, so it's going to be 2,5 dimethyl heptane. Okay, so let's do another one. Okay, so this one looks quite complicated. So what you're going to have to do is you're going to have to find the longest chain. So we're going to write the skeletal structure of it. And it looks like the best structure, longest chain will be something like that. Okay. You can try different ones, but that's probably going to be it. And here we go. So this is the longest chain, just like I showed you before, like that. Okay, and so what's the longest? So it's, how many is there? 1, 2, 3, 4, 6, 7, 8, 9. Okay, so this is the no name. All right, next thing you do is you circle the groups. So you have a methyl here, and an ethyl, and a methyl. So I put their names up here. So we're going to again have a dimethyl and ethyl. We'll see how to name these in a minute. So now what you have to figure out which direction is better for numbering. Okay. All right. So if we go, we start from this carbon right here, it would give me 4, 4, 6, 7. So if we start going this way, it would give me 4, 6, 7. And if we go this way, it would give me 3, 4, 6. So I'm going to go start over from this carbon right here and go 1, 2, 3, 4, 5, 6. So it's going to end up being a 3 methyl, 4 ethyl, 6 methyl. So put it all together, and you get you have the 2 methyls. So you grab them up as 1, 3, 6 dimethyl, and then 4 ethyl. Now you might say, well, why doesn't the di go before D go before E? Because of the it's alphabetical. This is not part of the name. And when you alphabetical, it's methyl still. Ethyl becomes before methyl. But the name is still 4 ethyl 3, 6 dimethyl no name. All right, so let's do another one. Okay, so we just draw out the skeletal structure, but coming off each hydrogen, each carbon is a hydrogen. So if you put them all in there, okay, and you're responsible to do that. Even if I'll ask you on a test for alkanes, you won't have to put the hydrogens up, but I just put them in here just to have you count them all. You can see I missed one here. But you should be able to put all the hydrogens. You don't have to do that here. I'm just showing you where they go. So what you need to do is you find the longest chain. And the longest chain is straight across. You can also get the longest, so it's 1, 2, 3, 4, 5, 6. Also, the longest chain would be like this. But you're going to see it's going to end up giving you the same name. All right, so we're just going to stick with this guy right here. All right, so this is a hexane. Okay, so what you do is you you circle the alkanes, I mean the alkyl groups, and then what you have to do in the numbering. Okay, so the numbering. All right, so the numbering goes 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, now the interesting thing about this one, they both give you a 3, 4. This one gives you 3 ethyl, 4 methyl, and going in this direction here. So this direction, going left to right, you get a 3, 4. And going this direction, you get a 3, 4 as well. Okay, so they tie. So which one do you pick? Okay, when they tie, you start with the longest chain should have the lowest number. Okay, so you're going to go with this version here. Okay, so A works out because it gives the ethyl the lowest number. So it's 3 ethyl, 4 methyl hexane. Right, another example. Okay, so here's the longest chain, and it's a pentane, and you have your 2 methyls coming off. Okay, now, so you circle the methyls. Then you number the alkyls. 1, 2. Either way, it'll give you the same numbering. 1, 2, 3, 4, 5. And this one going left to right will also give you both of them come off number 3. Now, the thing about this one, so they both come off in number 3. So you have to put that down. You have to put down both of them as 3,3-dimethyl. All right. One thing, a lot of mistakes that students will make is that they'll see that since both carbons come off the same one, they'll just call this a 3-dimethyl. It's really hard to write with this thing, and leave off the other 3. This is wrong. Okay, so you have to tell that both of the carbons come off of that same carbon. So even though you might think that this implies that there is, even though it says di and it might apply to 3, you have to tell that both of them come off of number 3. So it's 3,3-dimethyl pentane. All right, so I'm going to give you a worksheet, a couple worksheets to have you practice those, and I'll go over those when I tell you how to review for this, get ready for this test. Okay, the next thing that we're going to talk about is something called cycloalkanes. And cycloalkanes are not straight chains. What they are is like this. Okay. So it's not a straight chain, but they form like a circle. Okay, and they're alkanes because there's nothing but single bonds between the carbons, and then the rest are hydrogens. So actually the generalized form for this guy, these guys, is this. The number of hydrogens is twice the number of carbons. So this is C4, and you can see that there's 8 carbon hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. So H8. And you don't have to memorize the formula. I'm just showing you that relationship. And so these are called cycloalkanes. So this guy would be called cyclo, because it has 4 carbons. It'd be cyclobutane. There you go. Okay, so let's just go about naming them. So again, here's the guy. This is cyclopropane, and this is the full structure. This would be a skeletal structure. And what we can even do is that we get lazy, and And instead of just drawing out each carbon here, we can represent a points. The points represent carbons, and the sides represent bonds. And we know that each carbon will have 4 bonds, so the bonds that we don't show are going to be hydrogens. Okay, so this is another way you could represent cyclopropane. On the previous one, this would be a way of representing cyclobutane. And if you want to do cyclopentane, I draw it something like that. Okay. So I want to name this molecule here. Okay, so it has, so each point is a carbon, and you can see that this has 6 sides, so this would be a hexane, and it's cyclo, okay, and it has a group coming off of it, and so that group is a methyl, so it's simply methyl cyclohexane. Now you can leave a space between the methyl and the cyclo, it doesn't matter, or you could put them together. Okay, how about this guy here? Okay, so another way you could draw this is square, and then like that. Okay, so this is a cyclobutane with a methyl coming off it. It's ethyl, so it's ethyl cyclobutane. Okay, how about this guy? So draw the structural formula of the following name. So I'll give you this. So suppose I give you this name. How could you draw it? So you always start out with, you start backwards here. You start, so you start with the parent, okay, and this will even apply to alkanes. So you write out the parent first, okay. So here's my parent, cyclopentane, and then you put the ethyls. So it really doesn't matter where you put the ethyl. I could have put the first one here, here, or here, or I could put the first one here. So let's say I call this number 1 ethyl. Then the second one has got to be 2 away from it. 1, 2. All right. Now all you notice is that I could have started here and called this 1 and be a 1 and be 1, 2 as well. I mean a 1, 3. Okay. All right. How about this name here? Okay. So this is 1 so we have draw our hexane. Okay, always start out with the biggest group, or the 1, so 1 ethyl, and then place, you could go right or you could go clockwise or counterclockwise. I decided to go this way. I could have gone that way. So I'll put a methyl at 3, so 1, 2, 3, and I goofed up. There should have been another one coming off here, so this is wrong here. So it's 4, 5. Okay. So 1, 2, so it's 1, 3, 1 ethyl, 3, 5 dimethyl. Okay, so just again, you know something about their 3-dimensional structures. They're not these molecules, even though we draw them straight, flat, turns out they're not flat at all. Okay. That's because they're because of the tetrahedral shape. Okay. All right. Next topic is just some chemistry to do with alkanes. I told you at the first PowerPoint that we won't be talking about a lot of chemical reactions, but I want you to know about this one, the combustion of hydrocarbons, because this is where hydrocarbons are applicable in terms of our use, is burning hydrocarbons for fuel. Okay. So when we get petroleum, those petroleums are hydrocarbons, and what we do is when we get crude oil, what we do is we distill it. And when you see those giant distilleries, okay, they have the giant columns. And these columns, what they do is they boil the petroleum, and as the gas rises, the gas starts to condense, and the gases, the different materials, condense to liquids at different heights in the towers. So that's how they're able to separate the different components of crude oil. So when they get oil, crude oil is just a big sludge of black brown stuff. Okay, and then when they distill it, they'll collect, first of all, they'll collect asphalt, tar, then they'll and so forth. And higher up is gasoline and natural gas. Okay, and you'll notice if you ever go through go by one of these places, find refineries, is that you'll see flames coming off the top of the distilleries, and what that is that there's natural gas being released into the air, and what they do is they light it so it doesn't go and pollute the air, and it turns out they're polluting the air by doing that. Okay, all right. Okay, you don't have to know this, but just point of interest. So the key thing about combustion is this, is that, and you don't have to write these chemical reactions, but what combustion is you take an alkane, or any hydrocarbon actually, and when you combine it with oxygen, like oxygen in the air, what it'll do in the presence of a spark, it will produce carbon dioxide and water. And really the big thing that it produces is it produces energy to move our cars or our bodies, or etc. Okay, so the key thing here is that you can combust. The combustion of alkanes needs oxygen, and it produces carbon dioxide and water and energy. And you don't have to write these out, you just have to know what I just said. Curious thing also is that that chemical reaction doesn't go to completion all the time. It doesn't form carbon dioxide. What it does is form carbon monoxide instead, and that could cause problems. It could kill you. And also, it's when your car does that, it's not getting very good fuel efficiency. And that's it for this PowerPoint. And next PowerPoint will be about unsaturated hydrocarbons.